ProfessorBlackOps, cybersecurity for the people. Let's get it. Alert CISA Protective DNS Service. The DNS service is basically how the internet works. I'm going to walk through it at a basic level, then move on up. The CISA is right there, cyber infrastructure. They're actually a government agency that puts out alerts for known bad vulnerabilities or attack or breaches. So that's the actual CISA report right there. It's a combination of, this one is a combination of NSA and the CISA. Protective DNS is essential to the operation of modern network translations, human-readable domain into a machine-usable internet IP. DNS makes navigating to websites, sending email, and making sure secure shell works in the connection is much easier. Once again, I'm going to put the links in the description. So let's kind of walk through basically what is basic DNS service and what it does. So that's a quick diagram. And basically, the PC makes a call. It gets your URL. Your URL basically goes to a name service. Your name service, it binds it to the IPs. The IPs is actually the internet address to where that website is, and it brings that address back to your PC. So that's a high level. Once again, the description will be in the URL will be in the description. So what actually are the services of a DNS? The first service of a DNS is a record. An A record links a domain to the specific IP address. So when you log into GoDaddy, they're going to show you the A record. The A record is going to actually be your website, which is your host, which are actually IP address. The second record is called a CNAME, which is where things starts to get a bit complex. They point users to a specific IP address instead of towards other domains. For example, Elegant Themes goes to www.elegantthemes. So basically, it's a synonymous. You can put 2 or 3 URLs and actually what website do you want to go through. Or 2. The MX record basically in a DNS is basically where you put your email forwarding, your email address, and your private email address, and your host email. That's basically how that website gets linked to an email address. So when you go on GoDaddy or any of the other websites, you put that information and it's going to actually build your DNS record for you. The name server. People use the term name server interchangeably with DNS server. To build fully accurate name servers or computers running DNS software, which assigns itself to the name server. In most cases, this is what is registered to be used. Once again, the links will be in the description. Zone files, including the DNS settings, they are stored with your name server. For example, each record associated with your domain goes into your zone file in a simple text format, which simplifies interpreting and migration process. So once again, this is how when you go to GoDaddy, you create your domain name. That's how it gets registered on the internet. So when you put that domain names in there, there's domain name servers really across the world. That information gets replicated on those servers, and that's why when people put www your name, it knows where to go to your host address to actually work. Time to live is a setting that tells your name server how often it should update your DNS record. For example, if you change your A record, your TTL is set to 2 hours. It won't stop propagating until that time. So you tell it how often it should go out and query, right? You don't want to make it too small because then it'll go out and query and put too much pressure on the name server. So most times it's either an hour or 2 hours to get your TTL working, which is time to live. How often should it check your DNS server to make sure there was no changes or updated to your records? So this is a summary page. An A record, the record that links your domain name to your IP address. CNAME, you can point domains to your URL. MX record, the type of records enable you to receive information, emails to your domain. A name server, these are your domain registrar or host provider DNS servers. Zone files, these files will store all your DNS related information and is stored on your name server. Time to live, or TTL. With this setting, you can configure how often your DNS configuration is updated. So that's basically a summary page of how a DNS actually works. So now what we're going to go through is when the DNS was first created, it was very unsecure. So these are ways to actually lock down your DNS to make sure it's more secure. So DNSSEC is one of the first things to try to lock down the DNS server. Creates a secure domain name system, adding cryptographic signatures to the existing DNS records. So basically, each one of those links or how it communicates to those different servers are actually encrypted. So DNSSEC actually brings encryption to that whole process. So we're going to talk about a couple files, high level, but we're not going to drill down into detail. But basically, that's actually HTTPS. When you see the lock, when you go to certain websites, this is actually doing, DNSSEC is actually doing that for the DNS server. So RSC contains a cryptographic signature. DNS key contains a public signed key. DS contains a hash of the DNS record. DNSSEC3 for a specific denial of service for a record. And CDNS key or CDS is for a child zone requesting an update to a DS record in the parent zone. So this basically just makes sure. Make sure all your encryption is encrypted, so nobody can listen to or take it over on the internet. Once again, a lot of people were taking over people's websites in the 80s, so DNSSEC came out to actually prevent that. So I put a couple checks in there to make sure you're doing your DNSSEC correctly. I put all the links into once again in the description. So we're going to walk through a couple high-level checks for DNSSEC. So DNS server implementation utilize cryptographic mechanism to prevent unauthorized modification of the DNS zone data. So if you go back and you look in the diagram, each one of those has keys. So we just want to make sure each one of those keys are using the correct ciphers to make sure they're being encrypted in the correct way. Once again, DNSSEC. The file must be owned by the account under which the name server runs the software. So when you run your DNSSEC, when you run your DNS software, you just want to make sure they are controlled by the same user and that your user is locked down. So these checks just once again goes out to make sure your DNS name server is protected at the highest level. Once again, DNSSEC, digital signature algorithms, DNSSEC enabled zone must be FIPS compatible. FIPS just makes sure the encryption you're using is government certified and it has been approved. DNS servers must provide the means to enable verification of a chain of trust among parent and child domain. If the child supports secure resolution service, if the main server replies an invalid or cannot be validated, many network functions and communication will be adversely affected. So there's a parent DNS server and a child DNS server. You just want to make sure those keys are updated and can communicate between the child and the parent and the child. So basically, if somebody takes over the child server, that key is probably going to get corrupted, so they won't be able to communicate, which is a good thing. That's how you secure your DNS servers. So once again, we just hit it at a high level. The DNS implementation must protect authenticity of communication session from zone transfer. DNS is a fundamental network server and is prone to various attacks such as cache poisoning and man in the middle. So like I said before, you just want to make sure those keys are good. If somebody tries to read their communication with a man in the middle attack, they wouldn't be able to read it because you don't have the private key of those two servers. So now we're going to actually talk about what is the protective DNS server. That's just added protection once again for your DNS server. The protected DNS server is the core capability is to categorize domain name servers on the threat intelligence. The servers typically leverage open source, commercial, governmental information feeds for known malicious software or malicious domains. The feeds enable coverage of domain servers found on numerous points of network exploitation lifecycle. Some of the solutions also detect novel malicious domains based on pattern recognition. The types of domains typically addressed by the PDNS system includes phishing, malware, generation algorithms, or content filtering. So once again, if somebody takes over as one of those servers listed on a picture, the root server, the DNS or the DNS cache, basically the service will say which one of those DNS servers got corrupted or attacked, and it create a list of those. Also, it'll check for malware or phishing on each one of those servers to figure out if they were corrupted. If you go to some of the bigger vendors for this, they keep a list of all things corrupted. They share a big intelligent database. So they know if you go to that particular DNS cache, they know if it's been infiltrated or has malware on it. And it would just tell you that that's a bad DNS server, and it wouldn't allow you to go out there and query information to go to that particular web server on the internet. So what is Protective DNS? Is a central operation to perform network training, human-readable, and DNS websites. The DNS was not built with the abuse of bad actors and intent of causing harm. So once again, that's just an extra protection on your DNS server to protect your company or your website. Once again, a high level, what does it protect for the PDS? Phishing, malware, domain generation algorithm, and content filtering. Once again, that was just a short video going over protecting the DNS. Most people don't even give DNS a thought, but we want to actually just, I guess, give it a thought and go through some of the ways to protect your DNS server. Once again, Professor Black Ops, this is my STIG series. Give me a like and a subscribe. Have a great day.